Humanity always transformed the world around us, not only for growing food or for shelter, but also literally taking matter and shaping it in a way that was more appropriate for our needs. This kind of manufacturing has been going on for thousands of years. And just as with every other economic activity, this is also becoming digital. Digital manufacturing, whether it is 3D printing proper, as we've come to learn and love it in the past few years, or other ways of making manufacturing smarter, the Internet of Things, or Industry 4.0, as it is called in Europe, are really promising to allow us to more efficiently control matter. So, Hannes, what do you think? Is this going to take over industries and transform them really profoundly?
Hi, David. Yes, definitely. This is a shift. The humans, we've also always wanted to operate and modify matter around us, design it for our purposes, and the tools we have at hand are increasingly powerful. Digital manufacturing, 3D printing, and ultimately self-assembling systems are really doing this for us. And we are going through a new stage in the industrial area due to the digitalization of all these technologies. So, as you always know, my favorite application is that we will turn biological machines into manufacturing devices. So I hope to touch upon that in our conversation today.
I'm sure we will. For me, it was fascinating that when MakerBot, which was one of the leading producers of 3D printers for the consumer space, came onto the market. Originally, they had open source printers that you could buy from them as a kit, or download actually the specs and build yourself. If you were lazy, you could also buy them ready made. Later, then these were substituted by closed source versions that created quite a ruckus in the community that was accustomed to the more open and inclusive attitude from the producer before. Well, the reason they were born is not technological. The reason they were born is because some fundamental patents in the field of additive manufacturing expired. And this allowed alternative players, rather than just the owners of the patents, to come onto the market. The consumer hype around 3D printing did not deliver on its promise, as it frequently happens in our field, where people enthusiastic about what the possibilities of a new technology are go beyond, and they really believe in their own utopistic vision. And actually, those people don't even mind that the reality lets them down, because oftentimes just the exhilaration of learning is enough. It doesn't have to become something that is sustainable beyond a closed or a limited group of enthusiasts. So that is the consumer part of 3D printing. But of course, the industrial part of 3D printing is now becoming a must-have component of those manufacturing processes that want to be able to iterate rapidly, learning from the market, and rather than having production runs of millions of pieces, maybe they reduce the productions a little bit, but are able to adapt much more rapidly to the demands, not only in time, but also with local varieties around the world.
I'm curious to hear, David, why do you think 3D manufacturing as a consumer trend, why did it fail?
The level of sophistication of the machines is such that the limited number of
Materials.
filaments.
Mm.
Yeah, the materials that they can work on, the extreme finicky nature of the machines themselves that often break as they heat the filament and they release the droplets. The head that releases the droplets is very delicate,
Mm.
and it has to be substituted. The machines themselves have to be carefully calibrated, and this calibration process takes time. Also, the time that it takes to prepare a given piece is considerable. It can be hours,
Yes.
and in the meantime, the machine has to be monitored, because in the middle of a 5 hour long printing process, it could go out of calibration, and then the piece, just goes on, but it is not usable. So all of these were contributing factors for the consumer level machines not go beyond those initial enthusiasts.
So was it an example of the hype curve again hitting us? I mean, we enthusiasts, we could see it happening, and we envisioned all these uses for the technology, and maybe our minds ran ahead of what the tools in front of us. Will we catch up, or?
This is fairly common. Yeah, this is fairly common in exponential times, where a more modest technology can deliver better results than not the advanced technology. This was the case with digital cameras
Mm.
that clearly were inferior to chemical cameras in the 80s or in the 90s, and even in the early 2000s. But the speed of development of the digital cameras caught on, and after a bit, no chemical camera could compete if you took into account the combination of being affordable, of being convenient, and more recently in pure performance as well.
Yeah, I mean the whole process of taking pictures nowadays and post processing them. Compare the paper pictures of old with cutting and looking at them and working on them, and the way we can modify digital images is of course way superior. Another trend, just quick deviation from the main topic, that I enjoy is the access now to broad spectrum cameras, which digital photography has given us. It's so easy now to take infrared, ultraviolet, and multispectrum images, and we can suddenly use these cameras for a lot of interesting applications. And one cool recent example is of course this eye diagnostics thing that you can add to a phone, and you can use it to diagnose eye disease, for example, traveling in the countryside in developing countries. And this is just many applications that are coming out of smart cameras as a platform.
So getting out of the analogy from digital cameras, the performance of 3D printers based on metal synthesis, fusing directly metal pieces for various kinds of applications today is clearly superior to what traditionally could be obtained by working the metal, carving out pieces. And as a demonstration, more and more pieces in an airplane where you fly are 3D printed. Currently, hundreds of pieces of an airplane are 3D printed, including pieces of the engine that now contains parts that could be hard or impossible to produce with traditional methods, that last longer, are cheaper, are lighter, and lead to reduced fuel consumption. So this is an example where the additive manufacturing process clearly is winning. And we are also seeing an ecosystem developing. A company that I'm an advisor of is called Authentize. It has been born out of Singularity University, and Authentize has a platform for supporting the digital manufacturing process from setting up the designs to uploading them to the 3D printing machines, monitoring while the parts are printed, and very importantly, assuring that during all these steps, everything happens to the maximum degree of accountability and in a verifiedly complete manner, so that the pieces cannot be tampered with or corrupted or whatever else.
Brilliant, excellent, inspiring example. So, what's your favorite application of 3D printing as of 2017, David?
Well, we have had software as a service for a long time, right? So we now have hardware as a service. Specifically in 3D printing, Shapeways is a leading 3D printing as a service company where creators of all kinds upload their beautiful designs and anybody can buy them with variations. My son, Cosimo, I have three children, and he's the middle son, is passionate about 3D printing. And for the past several years, he designed and then 3D printed in metal, so on Shapeways necessarily, because we don't have a metal printer in house, a 3D heart to give to his girlfriend on Valentine's. That is unique, and it is a beautiful gift. It really expresses the creativity and everything else. Now, this is, in my opinion, not only very nice, but it also exemplifies that contrary to 19th century and in 100 almost 100% 20th century industrial economics, today the value starts to accrue to the person who is creating an object rather than being extracted in proportion to the capital investment required setting up the production plant. Because for a 3D printer, it doesn't matter whether the object that it is printing is stupid or ugly or useless on one hand, or on the other hand, it is beautiful and valuable and has very high functionality. It is exactly the same. And the cost of setting up the one or the other is also the same. But rather than setting up something that is fine tuned for producing exactly the same part a million times over with no flexibility, a 3D printing efficient manufacturing process as a service can print stuff unique in one or 10 or 1,000 pieces, very rapidly evolving towards new kinds of applications. And whether 1, 10, or 100, the value that the person designing those products or parts created mostly accrues to the person rather than to the owner of the manufacturing plant.
It's true. Excellent examples. I think that there is a complementary dimension to traditional manufacturing and 3D printing. For large volumes and long production lines, traditional manufacturing still has powerful benefits of scale. So 3D printing and localized and personalized production has a niche, and it's a growing niche, but it's still very hard to compete with traditional large-scale manufacturing systems simply in terms of economy for producing thousands and thousands of similar units.
That's right. And when you need those millions of units, Yes, of course. Why not? And 99% of the time you will send the order to the Chinese, and then will deliver your order, and then hopefully you will need exactly the million units that you ordered rather than half a million, because it means that you threw the savings away in producing too much, right? Um, Another component to this is also how more and more objects are naturally becoming nodes on the Internet of Things. Very simply because the marginal cost of adding storage, communication, computation, um, uh, capacity like sensors and actuators, both for outside information and for the internal state of the object itself, this marginal cost is trending to zero. My favorite example in this is how 10 years ago I would speak to companies like Cisco and others talking about IoT. And I would tell them, listen, uh, everything will be internet connected. Your chair, your door will be internet connected. And people would, smirk or laugh or whatever. They wouldn't take me seriously. But today, when I am at a conference and I have people who are coming from afar, I ask them, "Did you sleep in a hotel the night before? And was your key a big brass thing that was designed so that you couldn't put it in your pocket walking out, and you left it at the reception desk, or was it rather a very nimble, programmable electronic key card in plastic, and the door had a sensor, and when you touched the card to the door communicated with the server, querying the server, can this person enter the room? And if the answer was positive, the door opened. And doesn't that mean that I was right? Your door is now internet connected. And Amazon is selling a kit that allows you to connect your door to the internet. This has been announced just a few weeks ago. It is a kit of a door key as well as a camera that you are supposed to set up in your living room, so that when the Amazon packages get delivered, they can be deposited inside your house rather than in front of your front door. We will see how um, successful this is going to be, whether our perception of privacy is going to be rewired by Amazon, and all of us will say, oh, yeah, that's perfectly fine. That is exactly what we want. Or some people will say, no, never, thank you. But these are examples of how everyday objects are now being connected to the internet.
And we are still just in the beginning of the Internet of Things, of the rollout of the Internet of Things, because we can imagine that, oh my God, I'm going to let a stranger in to deliver a package into my home. But when you think like that, you don't actually get your hand around the idea that you can lock all the other internal doors in your home. So you will actually just give the person access to the kitchen and the refrigerator if they want to put groceries in your home. But you can close all the other rooms because it will be so easy to connect and monitor them. I think that we are heading towards a society where my favorite example is that the pizza cartons will be locked. So they will be personalized, and only the person with the right fingerprint or chip implant or credit card will in fact be able to unlock a pizza carton for a pizza that costs $3 because it will be so cheap to do it.
Well, actually, it already exists, because there are in San Francisco robots that deliver pizza or other kind of food, and those self-driving cars, which very appropriately are not shaped like cars today, but they have a shape that is adapted to whatever they need to do, go very slowly on the sidewalks, and they contain the food. And when they get to the place, they are opened with a code on your smartphone. So, yep, your forecast already is being implemented.
This is the connected world. However, going back to, or perhaps connecting the ideas of food and 3D printing is one of my favorite topics. And unfortunately, we haven't seen enough applications of this, in my view. Here at Epicenter, where I work in the daytime, we when we have events, we try to 3D print chocolate. We often do it in the logo of a visiting company, or we do images that they can relate to, and it's a fun gadget. But I'm still waiting for my 3D printed pizza. I mean, that is a product that would certainly be very well suitable. Why do I should have a little robot to drive a pizza to me when I can ultimately print it in my own oven?
Absolutely. Um, Talking about biological components, certainly the Internet of Things has, in my opinion, two big challenges. One, um, our electronics today is made out of alien material, the rare earths coming from the asteroids that are unknown to the biological ecosystem evolved on Earth for 4 billion years. And we cannot afford to spread the trillions of sensors if they are going to pollute the biosphere. So before the Internet of Things delivers its promise, either we have to make sure that anything that breaks is collected and recycled practically at 100% rate, or as an alternative, that we start thinking about what it means to take advantage of the ultimate digital manufacturing process we call life. Because, of course, now we understand that life is digital. DNA and viruses and the bacteria and the cells respond to a digital manufacturing language. And synthetic biology is promising not only to help our health, but also potentially to reprogram uh, ever more intricately and deeply the biosphere, uh, having it compenetrate with the technosphere, where we understand the mechanisms of life and we can design entire ecosystems to correspond to our needs. Rather than having to intervene in previous ecosystems where we certainly screw things up, doing these experiments with our open eyes, helped with our AI co-processors, so that we can make them as complex as they need to be, so that they are rich in expressing all the variety of the biological life we see around us. And since these digital manufacturing processes are self-replicating, as you mentioned at the beginning, that is going to be very interesting to see, and of course, full with all kinds of hopefully non-fatal pitfalls.
Hopefully non-fatal indeed. So I think it's great that you bring up this distinction between the ecosphere and the technosphere, because my personal view is there is no limit between those two. They are already one and the same. Already we are living in an age where we are modifying the chemical makeup of the oceans and the makeup of the atmosphere. And we are doing this through the application of technology. It's just that we are often not recognizing this process, that it's actually we are causing these changes, and we should accept that
Absolutely, absolutely.
the whole
Humanity,
ecosphere.
yeah,
Yeah, sure, go
humanity
ahead.
has been doing geoengineering forever. Actually, not only us. Even bacteria are doing geoengineering, but bacteria have a hard time recognizing what they are doing. They cannot do their experiments with their eyes open. We have that power, and we have to take advantage of that power.
And we have
Um,
to take responsibility of what we're
Correct.
doing, because we're still in some ways on the responsibility level of bacteria. Oh, we're just putting out these things, and then we're debating whether that is having an effect or not. So of course we need to take responsibility for the stewardship of the ecosphere and the technosphere, and manage
Yeah,
these systems.
the way I think about it is that our extreme respect from for nature is programmed into us because we recognize how ancient it is, and we are drawn to respect the elderly. But nature actually is wise to a limited degree, exactly because it doesn't seek but local maxima, whatever it is optimizing for as soon as it finds a solution, it stops. We, on the other hand, uh, function at a different level, and we are able to examine the solution space and search for global maxima, at least within the means of the resources that we are able to dedicate to this search. So rather than stopping at the first solution, we may actually see that that is a kind of a dead end. That it would be much better, not to poke a hole in the retina where our nerves are mounted. Yeah, are mounted badly in the wrong direction, and then in order to connect our brain with the sensors, we have to bring the nerves and the nerve fibers through the retina itself, like nature decided it should be, which is kind of ridiculous. Um,
There are some
eh,
some funny design wire flaws in the human body. Exactly. Yeah. Go ahead.
yeah, and so what I share with you is this vision that the technosphere and the biosphere intermingle, but actually I believe that the biosphere is a subset of the technosphere. I give two examples to illustrate this. One is that as you go deep, solar energy cannot generate life after a few meters. But we can dig as deep as we want, and we can bring light down with LEDs and then grow food in 3 dimensions below the surface of the earth, feeding an unlimited number of people if we want to, limited only by the solar energy available. But the solar energy, that doesn't need to be only the amount that reaches the surface of the Earth, because we can put solar panels in space and then transfer energy as microwave. So actually, we are already, and this is the second part, extending the biosphere, also going out from the surface of the Earth, where the lack of oxygen is the limiting factor. After 3,000 to 4,000 meters, life cannot extend, but the technosphere can. And yes, today it is only 4, 5, 6 people who live on orbit, but 4, 5, 6 people living on orbit is infinitely more than zero. And they are the beachhead in a new generation of technological solutions merging with biological solutions, extending biosphere through the help of the technosphere to enormously larger degrees than today.
And this beautifully illustrates your point, David, of that the Earth biosphere only produces local optimum solutions. So yes, our local planet here is optimized for biological life as we know it, but it's certainly not optimized for a universal spread of life. So that takes a being with a different vision and capabilities, such as mankind, to actually bring our robots and machines and life forms onto all the other bodies of the solar system
And this
thereafter.
connects us back to digital manufacturing, because there is another startup that was born at Singularity University called Made in Space. They designed a 3D printer that was delivered to the International Space Station. Today, actually, there are two, and these 3D printers work in microgravity, zero gravity, and they allow parts to be printed in space, so that if something breaks, you don't have to wait for the next delivery, but you can produce it locally.
Are
And
you
Made
able
in
to
Space,
explain the technicalities? Sorry, yeah, are you able to explain the technicalities of how does it work with 3D printing in space, David? When there is no gravity, how can things take form?
yeah, already the 3D printers actually do not take advantage of gravity, because the droplets that are deposited by the nozzle are not they get attached to the other to the proper places by the printing head, and they then just stay in place, right? So it is not like in the traditional printers. It is gravity that is doing the work. So what Made in Space needed to do is just to make sure that the printer would work. The kind of work that the printer does didn't need to change too much, and then the certification process, the bureaucratic and the regulatory process to be able to bring the printer to the space station was also pretty complicated, as it happens these days, right? Sometimes an innovation can be done because somebody is persistent enough not only to overcome the technological roadblocks, but the regulatory roadblocks as well.
And the
But
social roadblocks is what we often encounter. We have all these
that's
great
right.
inventions, but the public acceptance is a whole nother battle, which is something we can also discuss. We saw it in the case of 3D printers earlier here that it didn't take off because there were no uses, but in the terms of genetically modifying organisms and using bacteria to produce foodstuffs, that is a strong public fear and resistance to the application of these technologies, and that is perhaps even harder to crack than the actually solving just the technological dimension of
Yeah,
having.
yeah, I agree. So, Made in Space announced recently a new generation of printers. These printers, rather than living inside the space station, will live outside the space station. And as a consequence, they don't have to um, be under the constraints of all kinds of design and regulatory issues that cannot allow the 3D printers evolve as they should. Just like uh, cars were horseless carriages, and with today's eyes, they look ridiculous because now they have all kinds of different shapes. 3D printers that are adapted to space look more like robots. These have hands that move much more freely than those constrained in a 3D printer that we are accustomed to see, and they don't take raw materials from Earth. They take raw materials from the moon or from the asteroids that get delivered to them from other robots. And then they create all the infrastructure for extending space based manufacturing. So, this, in a certain sense, also becomes a self propagating machine or self-propagating organism, very different from the ones that we know on Earth. But the possibility of heavy industries being space-based is, I think, very exciting.
I think, David, would it not be fair to compare these robots, 3D printing robots in space, with spiders? Spiders, after all, they crawl around. They can excrete their nets. They are, in some ways, walking 3D printers that can print three-dimensional structures.
Beautiful.
So
And
it's an image that we are well familiar with.
yeah, yeah, beautiful, beautiful. I think that is a wonderful analogy, and we will see. I love the images of the spider nets, and the spider silk is a wonderful, incredibly strong material. So I think that it is a great picture to envision what kind of unanticipatedly beautiful structures the space based robotic spiders are going to create out of material extracted from the asteroid belt.
Can't wait for it. So I
So,
had another. Yeah. So yeah, go ahead.
go, no, please go ahead.
Yeah, what do you see? I mean, besides space, what industries that we are currently using here at home, do you see are being most powerfully affected by 3D printing and digital manufacturing?
Um, I remember when televisions were analog. They were glass vacuum containers whose characteristics couldn't scale. We had an upper limit of something like 30 inches in tube cathode tube televisions. So when televisions became digital with LCD and LED screens, one of the things that all of us noticed is they became flat, and another is that their dimensions started to grow incredibly. And with the increase of the dimensions, the prices didn't grow because, yes, the largest LED television and now OLED, organic LED televisions are all obviously very expensive at the beginning, but you just wait a year or two, and all the prices trend to a minimum that is basically the cost of delivering them to the retail location where you pick them up. it is
True. I'm
it
sitting
is
here
little,
watching a. It's amazing. I'm sitting here watching a 3 by 9 meter LED screen here in my office, and I mean, yeah, this is. It's not a projector screen. We can do all kinds of digital
there you
imaging on
go.
these screens, and
So the same is now about to happen with cars. Cars were analog machines with their internal combustion engines, and the electric cars are digital machines. And it is not just the difference between how you fuel them with gas or with electrons. Just as turning televisions into digital machines did incredible things to them that wasn't possible to anticipate it to a large degree, turning cars into digital machines is going to create incredibly important differences. Uh,
like
Together
what?
with, well, it is not only the fuel, but also the fact that digital machines, nodes of the Internet of Things, being able to calculate and loaded with hundreds of sensors, the self-driving cars are going to decrease 10, 100, 1,000 times the cost of transporting atoms. The cost of transportation up until now has been limited by the necessity of putting a human there. And when you include a human in a process, that has a lower limit. It cannot go lower than something in its cost. But when you take the human out of the process, the cost plummets and just keeps going down, down, down. So today, if I tell you, oh, can you please bring this cup from Stockholm to
Cup of
Milan.
coffee?
Well, no, just the cup. Let's say maybe the cup of coffee, but let's say even just the cup. You sign a cup, and I appreciate your signing the cup with your personal signature so much that I want to have the cup. And you have to bring it from Stockholm to Milan. Well, the only way you can do it now is to put it into a cardboard box, and then have FedEx come and pick it up, or DHL, whoever, an express courier, and it is probably not going to cost less than $30 or maybe $50 or euros to bring it from Stockholm to Milan. And I may appreciate your signature, but I don't know whether I will pay 50 euro for a cup with your signature on it. But the self-driving atom transportation infrastructure is going to make it possible to make economical things that were not before. If it doesn't have to be very fast, it can take 3 4 days or maybe 4 5 days instead of taking one day like FedEx would make it happen. If the transporter uh, takes care of packaging flexibly, if transportation is able to be done without human intervention 100%, like already is happening at the starting points where automated warehouses in the dark fill most of the orders from Amazon, and for groceries in the UK, one of the largest warehouses for groceries is completely robotic. Those components are going to decrease the cost of transportation very, very strongly, and that means that yes, we may eliminate truck drivers, but maybe we will put back truck drivers or robot drivers in the process in the same numbers, except that the measure of what is being delivered is going to be multiplied tenfold or a hundredfold in terms of mass. So
I think it's a beautiful image that you're painting, David. If I can just try to illustrate, I imagine that I take this cup here in front of me, I put it in this little smart package. I simply just throw it out the window, having written your name on it. This little package will magnetically attach itself to the first, cluster of packages passing by. Maybe it's a car or truck or something, right down to some railway hub or something where it will just by itself attach itself to a bigger cluster by way of magnetics, and it transport itself, just like IP packages are
absolutely.
traveling on a network, and it will end up in your office, just like the email I sent you earlier will, have found its way through
And
servers.
the way I look at this is that we will be able to uh, analyze and make judgment about every little piece of matter. What today we call waste or garbage is basically going to disappear, because in every home there will be eager robotic arms waiting for nothing but for a piece of discarded something to be picked up, that the robotic arm will examine, and then it will inaudibly whistle for the next available transporter to pull up and take a gram or 10 gram or 100 gram, if it is a big piece uh, of matter, agree on the value of that piece of matter, formerly called garbage, and the Internet of Things network will then take care of where that piece of matter will be useful. And if that economic transaction is only 1 cent, that's fine, or even less, that's perfectly
The
fine.
network will trade with itself
Yes,
for that resource. It's brilliant.
that's correct.
um,
And the homes will be able to support themselves by providing resources to the network rather than being charged for the garbage that today we throw away.
And it would be amazing if these waste could be reused locally, of course. Maybe I'm too stuck in the mindset still of trying to avoid transportation, but ultimately it could go into a local bioreactor that would then provide the carbs for my 3D printer that prints the pizza the next week in my home.
Yes,
So
yes, a lot of this will be
we make
decentralized.
smaller local loops. Yeah, exactly.
Yes,
That's what I imagine happening.
yes. Wonderful. I think that we draw great visions far out in the future of synthetic biology and the technosphere extending into space. But we also gave some examples of startups that are already working on making this reality. So, thank you very much for the conversation around 3D printing and digital manufacturing, Hannes. I'm looking forward to our next chat.
Thank you, David, and talk to you again soon.